Our next problem, we're going to be looking at problem 5.B.2. And this whole section, 5.B, deals with subsets of the group of functions R to R. Now, in the main tutorial, I denoted this as just like this, which is kind of lazy notation. Pinter denotes it as f of R. This is for fancy F is for functions, and then, R, right? I don't know what to write there, real to real. And so in this question, we're asked to determine if the collection of all anti-symmetric, or I don't know what you call this, point symmetric functions forms a subgroup. So just to write down what that means, we have this as the group G, and H is the group of F in G, where f of minus x equals minus f of x. We remember, of course, that the operation on G is plus, right? The pointwise addition. So following the same pattern as before, we have our neutral element. The neutral element of G is the zero function. We have to ask, does the zero function have this property? Well, 0 of minus x is 0. In particular, that is the same thing as minus 0, which is the same thing as minus 0 of x. Anything times 0 is 0. The x doesn't matter. Perfectly good neutral element. For the inverses, we have to check that if f has this property, then minus f has this property. Well, minus f of minus x equals minus of minus f of x, because f has that property. And while this is the same thing as f of x, this seems to show to me that maybe I should just write f of x, right? That I can pass the minus sign through just as good. Still satisfied for inverse. The last part is we have to check closure under the operation. And so we have to check if f and g are in H, then so is f plus g. And so we remember f plus g of x is defined by f of x plus g of x. So we have to determine then, if I have f plus g of minus x, is this the same as minus of f plus g of x? Let's check. So I take f plus g of minus x, and by definition, this is f of minus x plus g of minus x. Since f and g are individually in H, I can regroup this as minus f of x plus minus g of x. And we know that that plus sign there is redundant. I can remove it. From here, we can see that there is a negative sign in front of both of these things. So let's factor it out. And now let's use the definition of f plus g again to write this as minus f plus g of x, which is what we wanted to prove.